All right, let's get into it. Today, we're cracking open a real classic from the coding archives. Case file number 3, the three-sum problem. Our mission? To take a jumbled mess of numbers and find the elegant solution hiding inside.
So here's our plan of attack. First, we'll get the details of the case. Then, we're going to organize the evidence because you can't solve anything in chaos. After that, we'll unleash our secret weapon, the two-pointer tactic. We'll also have to be smart about eliminating false leads. And finally, we'll wrap it all up with the detective's final report.
Okay, first things first. Every great investigation starts with a crystal clear objective. So what exactly is this threesome case all about?
Here it is, our mission brief. Given a bunch of random integers, we need to find every single unique group of 3, we'll call them triplets, that adds up to exactly 0. Now, sure, you could try to just brute force it, check every possible combination. But that's like trying to solve a crime by interviewing every single person in the city. It's inefficient and, frankly, a total waste of time. We need a much smarter strategy.
And this is the mindset we need. The clues are all right there, sitting in the data. Our job is to know how to look for them. So, where do we start? Well, just like any good detective showing up at a crime scene, our absolute first step is to bring some order to the chaos. It's time to organize the evidence. Okay, take a look at this. On the left, our clues are a complete jumble. Trying to find anything in there would be pure guesswork, a shot in the dark. But look at the right. After we sort them, the evidence is laid out nice and organized. I can't overstate this. This one simple step is the key to our entire strategy. So why is sorting such a game changer? Well, it gives us 3 massive advantages. First, it sets the stage perfectly for our two-pointer tactic. Second, it makes spotting and ignoring those pesky duplicate clues incredibly easy. And maybe most importantly, it lets us systematically and intelligently eliminate possibilities without chasing dead ends. Now that our evidence is organized, we can finally deploy our core strategy. We call it the two-pointer tactic. You can think of it like a pincer movement, with our investigators closing in on the solution from both sides. So let's meet the team, shall we? First, you've got the anchor. This is our lead detective who picks one number and locks down the search around it. Then we have 2 other investigators, the left pointer, who starts just after the anchor, and the right pointer, who starts at the very end. Their job is to scan inwards, getting closer and closer to each other.
Let's see them in action. Our anchor is fixed on -4. The left pointer starts at -1, and the right pointer is way over it too. We add them up. The sum is -3. That's too small, right? We need to get to 0. Now, because our array is sorted, we know with 100% certainty that to make the sum bigger, we have to move the left pointer to the right to grab a larger number. It's logic, not luck.
Okay, after we exhausted all the options for our first anchor, we move it 1 step to the right. Our new anchor is now -1. The left pointer starts at the next element, also -1, and the right pointer is at 2. We check the sum, and bang, it's 0. We found our first valid triplet, -1, -1, 2. We log it as evidence and keep going. But we're not done with this anchor yet. After finding a match, we advance our left pointer to keep searching. It's now at 0. The sum is 1. That's too large. And again, because everything is sorted, the only logical way to make the sum smaller is to move the right pointer to the left, to grab a smaller number. See how systematic this is? And this is just beautiful. It perfectly shows that pincer movement. The left pointer is at 0, and the right pointer has moved inward to 1. Let's check the sum. -1 plus 0 plus 1, and that is 0. We found our second valid triplet. The investigation for this anchor is now officially closed. We've found our solutions, but remember, the mission specifies unique triplets. This brings us to a really critical part of the investigation. How do we eliminate false leads? Or, in our case, how do we handle duplicate results? So, how do we deal with this? If you look at our sorted array, we have 2 -1s right next to each other. If we're not careful, we could easily end up doing the same work twice and reporting the same results. A good detective doesn't waste time. And here's the beautifully simple solution. When we go to move our anchor, we just ask one simple question. Is this the same number as my last anchor? When we get to index 2, the value is -1. But wait,
We already ran a full investigation with -1 as our anchor, back at index 1. So to avoid all that redundant work, we just skip it. Clean, simple, and super efficient. So we've found all the unique triplets, we've figured out how to avoid duplicates. It's time to file our final report and officially close this case.
So how efficient was our investigation? Well, our time complexity is O(n)², or n squared. What that really means is for every number we anchor, we do a single quick scan through the rest of the list. Compare that to the brute force O(n)³ approach, the difference is staggering. And what about space complexity? It's O(1), which is basically perfect. It means we solved the whole case without needing any extra storage space. We worked right on the evidence we were given. And that really brings us to the core principle here. We didn't get lucky, we didn't guess. The solution revealed itself through a methodical, structured process of elimination. And it was all made possible by that one critical first step, organizing the evidence. You know, this two-pointer tactic is so much more than just a one-off trick. It's a powerful pattern, a way of thinking you can use for all kinds of searching problems in sorted data. We used it to crack the three-sum case today. The only real question left is, what case are you going to crack with it next?